Okay, in this brief video, I wanted to show you how to find the derivative of something like x to the x, or maybe the derivative of, let's say, ln x raised to the power sine x, assuming that ln x was not negative. So basically greater than 0. And I think also you kind of have to be careful with ln x equaling 1. Yeah. So anyway, in other words, this would be basically this would be x is greater than 1. And this would mean x is not e. Okay. So anyway, on the domain where this is defined, what would be the derivative? So these kinds of questions are not power rule. They're not really e to the x type problems, right? They're just like their own kind of problems. And so giving it the respect it deserves, we should probably do these one at a time and just use our best thinking skills here. So since the x is both in the base and the power, we don't really have a way to start this problem. So what we're going to do instead is we're going to shed the whole d dx thing. We'll bring that back later. And we're going to label this as y equals x to the x. The reason I'm doing this is because one of the most powerful things we've ever learned is implicit. It is just that powerful. So now I'm going to put an ln on both sides. Now this is not because I want to find the derivative. This is because I don't know any other way to deal with this x power thing. So now I'm going to take this x and put it in the front. That's not calculus, that's just math 3. And this gives me a much easier statement to understand. So I have an ln, so I have an x and then an ln x. There we go. So I really like the way this is written. I feel like this is something I could easily do the derivative of. And it is true that I put this blue ln in here and probably ruined the problem, but I can fix that later. Okay? So now I'm going to find the derivative of both sides. I guess there's an ln here, sorry. So there's an ln here and there's an ln here. But let's get started. So now I'm going to put a d dx on both sides. So derivative of ln y. And then on the other side, derivative of x ln x. Okay, the left side is pretty easy. It's just 1 over y times dy dx. Notice it's 1 over y because it's an ln, and it's dy dx because we have this variable mismatch. On the right side, it's definitely a product rule, the derivative of x times ln plus derivative of ln times the x. Okay, so we end up basically with dy dx equals y times ln x plus 1. That's if you bring the y to the right side. Multiply the y to the right side. Okay, so that is interesting. And since y was originally x to the x, remember, y was x to the x, I can just rewrite that, put that right back in again. So my answer is, the derivative is x to the x times ln x plus 1. Very interesting. All right, now let's go and try this other problem here with all the weird domain issues, but let's just try it. So forget the domain issues, forget the d dx. Let's just put the d dx back in later on the implicit steps. So we definitely need to start with a y equals ln x to the sine x. I'm going to take this equation and I'm going to slap an ln on both sides. 1, 2. For no other reason than I wish to just have this put out front. That's the only reason I'm putting the ln into this problem. So now I have ln y equals sine x, and then kind of weird, but I have an ln ln. Okay, fair enough. Now I'm going to find the derivative. So this is the time to, write out the derivative. So let me just be really, really thorough here. I like to be super thorough. I'm going to put that d dx right there and right there. On the left side, it's very similar to last time. You get 1 over y times dy dx. For the right side, again, like last time, a product rule. This time it's a little bit nastier, but it is nonetheless a product rule. So the derivative of sine, then the ln. Then we have the derivative of the ln. So how does that work? What is the derivative of ln of ln? So the derivative of ln. I wonder what that looks like. Well, first you start with 1 over. So it's obviously 1 over ln. Then you multiply by the derivative of what's inside, which is 1 over x. So it's kind of weird, but there's a 1 over ln and there's a 1 over x in that order. And then we have another sine x here. So as awkward as it was, if we bring that y over, we have a nice little cosine ln. And we have a sine over x ln. If you put the original function back in where it says y, we have the derivative is ln x to the sine x times cosine ln. Oops. Cosine ln plus sine over x ln. Okay, so notice we were able to do this. There were domain issues, real serious ones, regarding the bases, especially anything, in this location. You have to be real careful with those. But we did successfully find, the slope function. And if you try to draw this stuff on Desmos, it's just scattered dots everywhere, and it's, not very clear what's going on. But we know we did it correctly for the domains that are legitimate. So this technique is called logarithmic derivative, and that's because we put in this ln here, if for no other reason, just to bring down the power to the front. And we had to do that because having these in successive power, like having a base that's x and a power that's x, makes it very challenging to do this any other way. But I'm glad we pulled the sine x down so we could use our nice product rule. So I wanted to show you these so that you guys can get a handle on those kinds of problems.